All right. I understand that Math Excel's been down a little bit this week because what happened on Monday and Tuesday is the start of all the college classes all over the country. So their servers just got overloaded with all, so many colleges signing up for classes and that. And so that's why it's been down a little bit. So you don't have to worry too much about that. We'll get your homework done. I'm not going to talk, hopefully, too long this morning, so you get some chances to get things caught up in here. I haven't put anything in the grade book, I think, yet. Have I? No. So except for, the graphing calculator number. So I'm not going to worry too much about it. Nobody's going to be on study table this weekend from in here. So we'll be good. Friday, I got a funeral to go to, so I will be gone. I will probably record a really short lesson and let you guys figure out what's going on with it. So, yeah. So that's what's going on there. Okay. And I'll even maybe make it even more obvious than what I do with this stuff. Okay. So what we're dealing with is symmetry today. Okay? We've all seen f of x equals x squared. Y equals x squared. That is a parabola. You've worked with parabolas a lot in Algebra 2. Okay? So, since you've worked with parabolas, you understand they're symmetrical with the y-axis, especially when they surround it. Now, if we had like x minus 4 quantity squared, that one's like over here. It's still symmetrical with the y-axis. It's just moved over from the y-axis. But it's still basically symmetrical with the y-axis. Okay? Now, a function that acts like this, that has the same values of y for a negative value of x as a positive value of x, is said to be an even function. Now, you guys were in trig, right? Most of you have been in trig. Remember, the sine function looks like this, and this is sine, and then the cosine function looks like this. Boy, that's a bad drawing. But see how cosine, the x and the y's are the same as a mirror image around it's basically a mirror image around the y-axis, just like a parabola is. Cosine functions were even functions. Sine functions were odd functions because they're a flip and a flip. If you flip and a flip, that's an odd function. If it's just a flip across the y-axis, then it's an even function. Okay? So you have to know the difference between an even function and an odd function. Why do they call them even and odd? Look at that power. Okay? If it's squared, it's an even function. If it's a cubed, it's going to be an odd function. Okay? Because if we reflect it across the x-axis or y-axis and then across the x-axis, a flip and a flip, you can see that these values and these values are opposite of each other. Okay? The x and y and negative x and negative y mirror each other, basically. Okay? We can have functions that are symmetrical with the x-axis, x equals y squared, okay? But we don't call that even or odd, okay? We really don't call that even or odd. Okay, so we're wondering, is this even, odd, or neither? Okay, so to check if it's even or odd or neither, we figure out what f of x equals x squared plus 3, and f of negative x, if we put a negative x in here, we get x squared plus 3. See how they match. If they match, it's an even function. Okay? If you put a negative x in for the x's and they match, it's an even function. If you put a negative x in and it becomes the absolute opposite of it, then it's an odd function. Otherwise, it's neither. Okay? Asymptotes. Okay? Asymptotes. So, if you have a vertical asymptote, something can never cross it. So a lot of times they look like this. A function looks like this, where it cannot cross an asymptote. It goes down like this and down like this. Okay? If it's a horizontal asymptote, they can cross it. And we have functions every once in a while that have a couple vertical asymptotes. And like this part might be up here, this part might be down here, and it might go like this. Now, there is a horizontal asymptote going on here where as you go towards infinity, it gets closer and closer to the x-axis. And if you go towards negative infinity, it goes closer and closer to the y-axis. Maggie, you shouldn't be playing Tetris right now. Okay. Okay. I thought you were staring at your computer doing something. Oh, okay. All right. That's good to know. So, and then this goes towards the vertical asymptote, and this goes towards the vertical asymptote. Okay? So, to find horizontal and vertical asymptotes, to find a vertical asymptote, you set the denominator equal to 0. Okay? Set the denominator equal to 0, factor and solve. So we get x and x, plus and minus, what and what? How's that factor? 1 and 2. So x plus 1 equals 0, x minus 2 equals 0, x equals negative 1, and x equals a positive 2. So you have vertical asymptotes at both negative x equals negative 1 and x equals negative 2, x equals positive 2. Okay? Horizontal asymptotes, these are the fun ones. Okay? For a horizontal asymptote, if you have the same power, so like nx squared, mx squared, okay? If you have the same power on the top and bottom, the horizontal asymptote is the coefficients of both of those. So the horizontal asymptote will say y equals n over m. If the highest power in each is the same power, then it's the top number over the bottom number. Now, if these are both 1s, your horizontal asymptote is 1. Okay? If you have the bottom power higher than the top power, your horizontal asymptote is going to be y equals 0. So if your bottom power is going to be higher than your top power, your horizontal asymptote is going to be 0. Okay? And if your top power is higher than your bottom power, there's going to be no horizontal asymptote. We're not going to have a horizontal asymptote. If the top power is higher than the bottom power, we're not going to have a horizontal asymptote. We might have a hole in the graph. We might have a slant asymptote, which it's called, but we won't have a horizontal asymptote. Okay? So that's how to figure out horizontal and vertical asymptotes. Vertical asymptote, you set the denominator equal to 0 and you solve. Horizontal asymptote, you got to look at the powers, and it's the highest power. Okay? So on this function, what would the horizontal asymptote be? 0, because the top power is smaller than the bottom power. top power smaller than the bottom power, horizontal asymptote is 0. Okay? So that's how you work with horizontal asymptotes. And they were just working through that. So that's the basics of this section. You might have a few questions on this. That's fine. You got to figure out if functions are odd or even or neither. And then you got to look at asymptotes. There's like 7 or 8 questions is all. I keep these assignments fairly short because we have a before lunch and after lunch. And so then I can try to keep them fairly short.